Hi, good evening. So shall we start with today's session? That's nothing what we are going to solve the PYQs. At the same time, we are going to discuss all the concept of the 2 degree of freedom system. And again, here we are considering the system is what it's a undamped 2 degree of freedom vibration systems. Now, could we draw here like the generalized diagram for a 2 degree of freedom system? Let's consider if we are having any system something like this. Let's say we are having the two masses connected in this fashion. Let's say this is mass M1. This is nothing what you can say, the mass M2 here. And there is one more spring. Now, let's define, let's say this is a first spring having the stiffness K1. This is second spring having the stiffness K2. And this is nothing what you can say, the third spring. That's nothing what you can say, that's a K3 here. What? K3. Now, could you tell me, like in these kind of the questions, what is required? Anyone? This frequency equation is required. So could you tell me, like, what is the frequency equation of this kind of motion is going to be? Anyone? Yes. Huh? Yes. Minus
K1 plus K2 multiplied M2 plus K2 plus K3 into M1 whole omega square plus K1 K2 plus K2 K3 plus K3 K1.
Okay. Okay. So see, if you are going to solve these kind of the problems, just remember a single frequency equation. That's nothing but we can write. Yes, Ajay, could you tell me? Or Bidhi, it is going to be M1 M2 omega raised power 4 minus how much? In bracket you can write. Yes, anyone? Yes. What is the frequency equation?
M2 omega raised to 4 minus omega square M1 K2 plus K3 plus M2 K1 plus K2 bracket close plus K1 K2 plus K2 K3 plus K3 K1 is equal to 0.
Okay. So this is nothing what you can say M1 M2. What is M1 M2? These are nothing what you can say the first mass and second mass. What is omega here? That's a frequency we are considering. That's a frequency of a harmonic motion. Done. Here it is going to be, it is K2 plus K3. If you are taking this K2 and K3, then this first mass comes here. That's a M1 plus how much? K1 plus K2. What comes here? M2. Check please. Bracket close. Omega square plus how much? Anyone? Simply K1 K2, K2 K3 and K3 K1. That's the addition of these three terms. K1 K2 plus K2 K3 plus K3 K1 is equal to 0. Is this visible to you? Yes. Online class, is this visible?
Yes,
please
sir.
confirm. Okay. Now, one more thing. What is the value of, you can say, x1 upon x2 in this case, if you are going to derive? Yes, anyone? K2, yes, divided by how much?
K1 plus K2 minus.
Sorry, what you said?
K2 upon K1 plus K2.
K2 divided by,
Minus M1 into omega square.
Minus M1 omega square. Okay. Anyone in online class? Yes. What is the value of x1 upon x2 is going to be?
K2 divided by minus M1 omega square plus K1 plus K3.
K1 plus K3. Really? K1 plus K3.
K1 plus K2.
Yeah, that's correct. It is going to be K1 plus K2 minus M1 omega square. If you know these two things, you can find out the nature frequencies, or you can say mode shape of any 2 degree of freedom system. Now, what are the chances? Let's say the examiner is saying K1 is equal to K, K2 is equal to K, and K3 is equal to K, and M1 and M2 is equal to M, or any other value. Just substitute the corresponding value here. And as you can see, this frequency equation is nothing what you can say, it's a quadratic in omega square only, right? So just by, like how to solve the quadratic equation. If suppose if you are having any quadratic equation like ax square plus bx plus c, how to calculate its roots? You can say x is equal to minus b plus minus root of b square minus 4ac divided by 2a. So that's what is required to solve such kind of the problems. Is that clear? For example, if you are considering k1 is equal to k, k2 is equal to k, and k3 is equal to k, and you are taking m1 is equal to m2 is equal to m, then how to find out the frequency of the system? Anyone? Just replace m1 by m and m2 by m here. K2 and k3 are nothing what you can say k. So it is going to be how much? 2km. This term is also going to be 2km. Why? Because k1 is equal to k2 and m2 is nothing what you can say m. And here, what you can write? You can say it's a k square plus k square plus k square only. Just find out what is the root of, you can say, this particular equation, or you can say the frequency equation. Those are nothing what you can see on natural frequencies only. No need to write like what is the equation of motion. Is that clear? You are appearing in a competitive exam. It's not a academics where you should have to write down each and every equation, like what is the equation of motion of first mass, what is the equation of motion of second mass. It will take 5 to 10 minutes. Is that clear? So to solve these problems, or you can say these kind of the problems, what is you can see the requirement? It's just only the understanding of, you can say, the quadratic equation, like how to find out the root of any quadratic equation. Done. For example, let's say if I'm saying m1 is equal to m2 is equal to m, k1 is equal to k2 is equal to k3 is equal to k, could you tell me like what is the natural frequency is going to be? Just substitute here. I can write the equation of motion, write down the frequency equation. Could you write down, please? Write down frequency equation is going to be, it is m square omega raised to power 4 minus how much? Just substitute k2 is equal to k and k3 is equal to k. I can write here that's a 2km plus 2km bracket close omega square. Then plus how much you will get? K1 is equal to k2 is equal to k3 is equal to k. It means that this is going to be 3k square is equal to 0. Done. Solve this one further. We can write it is going to be m square omega raised to power 4 minus how much? 4km omega square plus 3k square is equal to 0. Find out. Here you can write the above equation. The above equation is, I'm writing just for your understanding only, okay? Is it the above equation is quadratic in omega square. Therefore, directly we are getting the value of omega square is equal to how much? Simply you can write down minus b. So here if you compare, let's say omega square, if you are considering say x, what you are considering? Let's say omega square is nothing what you can say x here, or simply you can write omega square, then what it is going to be? Minus b. So minus 4km. Okay, let me write here ax square plus bx plus c. That's a quadratic in what? It's a quadratic in x. Here, this equation is quadratic in omega square. It means that what is the value of b is going to be? If you compare with the quadratic equation in x, it is going to be 4km. So minus minus becomes what? Plus only minus b. This is already minus. It means that minus minus is 4km plus minus root of how much? Anyone? B square minus 4ac. So what is the b value? That's going to be 16k square m square minus 4. A value. What is a? That's nothing what you can say m square. And what is the value of k is going to be here? Sorry, what is the value of c is going to be? That's nothing but how much? Into 3k square. Could you check? Could you verify, please? Hello?
Yes, sir.
Are you there? Is this correct or not? Divided by 2a. So what is the value of a? This is a we have taken. This one we have taken b. And this one we have taken c. Please take care. So it's a 2a is nothing what you can say 2m square. Done. Now, if you simplify it further, you can write omega square is equal to, that's a 4km plus minus 4 3s are 12. How much you will get here? 12k square m square. Already, how much we are having? That's a 16k square m square. It means that how much you will get? That's a 4k square m square inside this root only. So this value is going to be, if you simplify this, it is going to be 2km, right? Could you verify, guys? Divided by 2m square. Are you getting this one? First say yes or no, sir.
Yes,
Is
sir.
this okay? Now, since it's a 2 degree of freedom system, it means that how many mode shape are there and how many frequencies are there? 2 frequencies are there, and corresponds to each frequency, we can have x1 upon x2 value. We can write for omega n1 as well as for the omega n2. So the next question is that which one is going to be the first natural frequency, the highest one or lowest one? Look, if you are calculating the omega value from here, one value is going to be 4km plus 2km divided by 2m square. Simply you are calculating root only, right? Another one is going to be what? 4km minus 2km divided by 2m square. So the question is that which one is the first natural frequency? The lowest one is the first natural frequency. Please take care of it. Okay. So here we can write simply omega square. There are two possibilities. One is what? 4km plus 2km divided by 2m square. Another one is what? 4km minus 2km divided by 2m square. If you simplify it further, could you tell me how much you will get? It is going to be how much? 6km divided by 2m square. So 6km divided by 2m square. And this is going to be how much? 2km divided by 2m square. If you simplify it further, what you can write? 2 get cancel. M and this power is gone. 2 3 just 6. This m and this power is gone. It means that omega, sorry. Yeah, I'm writing omega square now. 3km it is going to be, right? So it is going to be 3km divided by, sorry, not 3km. It's a 3k upon m, comma. This value is going to be how much? K by m, right? So from here I can write. So first one, here I can write omega 1 is nothing but you can say, or omega 1 square is nothing but you can say that's a k by m. It means that the omega 1 value is equal to root of k by m. See, I'm solving step by step. Otherwise, it will take, you can say, hardly 1 minute to calculate the root of, you can say, these kind of, you can say, the equations. Okay. Since it's a revision, so still I'm following the step by step procedure. So omega 1 is this one. What is the value of omega 2 square? That's nothing what you can say. That's a 3k by m. It means that what is the omega 2 value or omega n2 value? That's nothing what you can say, 3k upon m. Now tell me, is there any requirement of writing the equation of motion of, you can say, for the first mass and second mass, which is nothing what you can say, the differential equation of motion, right? Say yes or no, sir. Again, the system is what? The system is a discrete system. Means the mass is lumped, or you can say the concentrated at a certain point. Is that clear? It's not a distributed mass, or you can say the continuous system. Then it means that it is having the finite degree of freedom. That's a basic understanding of which systems. That's a discrete systems, right? So two mass, in this case, we are having, this system is representing the 2 degree of freedom system. Which one? 2 degree of freedom. Now, what about the mode shape of, you can say, this particular, you can say, the system? Simply I can write x1 upon x2 corresponds to omega n1, and x1 and upon x2 corresponds to omega n2. You know very well, like what is the value of omega 1 and what is the value of omega 2, as well as what is the value of k2, what is the value of k1, and what is the value of k2 in this equation. Okay. We are also having one more equation. Generally, when we used to derive this equation, generally we have to get one equation, or you can say one value of x1 upon x2 from the equation of motion of, you can say, first mass, x1 upon x2 value from the equation of motion of second mass, right? If we equate these two, what you will get? You will get this particular equation. Which one? This one. Could you remind? Say yes or no, sir. Hello, guys. Those who are
Yes.
online, please.
Yes, sir.
Are you getting this one or not? Okay, very good. Now, once we get this one, we can calculate the x1 upon x2 corresponds to, you can see, the first natural frequency or first mode is nothing but omega n1 is going to be, k2 is how much? That's a k. And what is k1 and k2? That's a k only. So k plus k is nothing what you can say. That's a 2k. If it is 2, okay, let me write here. Okay, k2 is k divided by 2k minus m1 is m, and here you can write omega 1 or you can say omega n1, both are same here. Omega n1, omega n2 means this is a second nature frequency. And what do you want? You want the x1 upon x2 value corresponds to omega n1. Could you tell me how much we'll get? Just substitute the value of, you can say, the omega n1 in this case. So how much we'll get? Omega n1 is root of k by m. So omega n1 square is going to what? K by m only. So if you substitute the value of omega n1, it is going to be, guys, k by m only. Say yes or no, sir. This m and this m is get cancelled. Ultimately, you are getting k divided by how much? 2k minus k. It means that this value is nothing but how much? K by k means corresponds to the first natural frequency. We are getting the mode shape u is equal to 1. Are you getting? First say yes or no, sir. Hello, am I audible or not?
Yes, sir.
Now, the next question is that, like, what is the second mode shape is going to be? The second mode shape, again, by using the same formula, we can calculate x1 upon x2 corresponds to this omega n2 is going to be how much? Look, same formula. What I'm saying? Same formula we are going to use to calculate the value of, you can say, the second mode shape. Just you have to change this omega n1 by omega n2. Done. Here I can write that's a k2 divided by how much? Yes. Yes. How much? K1 plus K2 minus M1 omega square. So here you can write that's a K1 plus K2 minus M1 omega square. So if it is omega square means if you're calculating corresponds to the second natural frequency, please remember, first you have to change this omega by omega n2 only. Done. Now just substitute the value of K2, K1, M1 and omega n2, we will get the mode shape here easily. Here I can write this is going to be k divided by 2k means, please remember which case is this? K1 is equal to K2 is equal to K3 is equal to K. Done? First say yes or no, sir, ladke. Now 2k minus m, what is the value of omega n2? That's a root of 3k by m. So this omega n2 square is going to be 3k by m only. So here I can write into 3k divided by m. So this m and this m get cancelled, and ultimately you are getting k divided by 2k minus 3k. Are you getting this one? First say yes or no, sir, please, for God's sake.
Yes, sir.
If you simplify it further, how much you're getting? K divided by minus k. Done. So I can write here this x1 upon x2, that's a mode shape, corresponds to second natural frequency. It is going to be minus 1. So the question is that, what is the meaning of this mode shape here? If you are getting the plus and if you are getting the minus, what is the meaning of that? Anyone? See. Oh, sorry, just wait. Look carefully what I want to convey. If you are getting x1 upon x2, what is x1 here? Amplitude of the first mass corresponds at omega n1. What is x2? That's the amplitude of second mass, corresponds to the first natural frequency, or you can say this is corresponds to the first mode here, right? Let's say, please remember, in this case, there is a relative motion between, or you can say these two masses are coupled by this spring K2, right? So this mode shape generally tells us like how the displacement of these two masses takes place. So if it is coming plus, it means that the motion of these two are nothing what you can say, it's in phase. What it means by in phase? Let's say this is the first mass m1 and this is nothing what you can say second mass m2, and let's say these two masses are connected by these two masses, which is nothing what you can say K2. It means that if one mass is moving in the downward direction, then the second mass will also going to move in the same direction. For example, let's say this m2 is moving downward, then the m1 will also move in downward direction, something like this. If the M2 is moving in the upward direction, then the M1 is also moving in the upward direction. Is that clear? So this is the in phase. If it is coming positive, what it means to be negative? Negative means out of phase. Means if the first mass is moving in upward direction, then the second mass will move in the opposite to it. So the motion is like this. Is that clear? Hello? Are you getting this one?
Yes,
We
sir.
have already discussed these all things you can see during the classes, right? So in phase means both the masses are moving simultaneously in the same direction. If the mass M1 is moving in the downward direction, then the second mass will also move in the downward direction. If this first mass is moving in the upward direction, then it will also move in upward direction. So the motion is going to be like this. Is that clear? And in this case, if it is coming x1 upon x2 is equal to 1, it means that what? Huh? Then there is no deflection between these two springs. Are you getting? Please take care of it. We are not getting any kind of, you can say, deflection in the second spring. If suppose it's a 0.5, then obviously the x1 and x2 means the amplitude of two masses are going to be different. If it is coming 1, it means that both are same. x1 is equal to x2. Simply, if you are writing x upon y is equal to 1, what is the meaning of that? X is equal to y only. Say yes or no, sir. If you are writing a by v is equal to 1, means what? A is equal to v. In this case also at natural frequency, or you can say first natural frequency, you are getting the amplitude of, you can say the first mass is exactly amplitude of second mass. And generally we also used to write this one by this symbol, let's say phi 1, which is nothing what you can say matrix form. So if you are getting it's a 1, it means that what? You can write this is nothing what you can say x11, and this is nothing what you can say x not 1 2, it is 2 1, right? Please take care. How to understand this one? Please remember, if I'm writing xi comma j, then please remember I defines what and j defines what. Could you tell me what defines this I? I defines the coordinate. What it defines? Coordinate. And what this j defines? Defines like corresponds to which frequency, which omega, whether it's a omega 1 or omega 2 or omega n1, or you can say the omega n2. So please remember, if you are writing this x1 is nothing what you can say the x11, we can also write instead of writing x1 upon x2 at omega n1 or omega 1, simply it means that the amplitude of first mass corresponds to what? First natural frequency. Similarly, the amplitude of second mass corresponds to what? First natural frequency. So please remember, this defines like corresponds to which mod, or you can say which frequency. Or simply you can write which omega means first natural, or you can say the second natural frequency. Any problem? Hello? So we can also write in matrix form, and again I can define what is this phi 1 is going to be. From here, what you are getting? Simply you are getting x1 is equal to x2. It means that what I can write in matrix form, I can write like this only. Done? First say yes or no, sir. Hello, hello, hello. Yes. Are you getting? Similarly, which kind of motion is this? If you want, you can write here. This is nothing what you can say. Where is the? You can write this is nothing what you can say, it's a in phase. Which one? In phase motion of two masses. Here you can write, since you are getting x1 upon x2 is equal to -1, meaning what? If you calculate, you can write x1 is nothing but you can say minus x2. So what I can write here? I can write here this phi 2 means mod shape of, you can see this corresponds to the second nature frequency, or second mod is going to be how much? Please remember what I told you. X I C. So I defines what? Coordinate, and J defines what? Corresponds to which frequency you are calculating the mod shape. So here it is x1 again, but please remember corresponds to which frequency? Second natural frequency. So it is going to be x12 divided by x22. x12 and x22. Take care. And if you want to take the ratio of these two, I can still write this is nothing but you can write same value. I can write it's a x12 divided by x22 u is equal to -1, it leads to what? Means x12 is nothing what you can say minus of x22. Done? Since both are same, see magnitude wise, please remember, if you are writing by u is equal to minus x or a equal to minus b, what is the meaning of that? Magnitude wise, you can say both the values are same. Is that clear? But here, if you look at this minus sign, it tells us like how the two motions are related to each other. So if the one mass is moving in the upward direction, second mass is moving in the downward direction. So the motion is going to be like this in this particular mode. Is that clear? First say yes sir or no sir. Are you getting
Yes,
this
sir.
one?
Yes, sir.
Let's say this is the first mass, this is second mass, this is the, you can say spring, which is connecting or coupling the two masses here. So it will reflect something like this. I hope you can relate it. So again, I can define this is going to be the substitute here. If you are considering x11 is 1, then x22 is nothing what you can say e minus 1. So this is the matrix form. Again, we can also write something like this 1, comma, -1. This is nothing what you can say the transpose of this matrix. Shall I write? Any issue? Simple, it's a mathematics only. First say yes sir or no sir. Hello, hello. First say yes or no.
Yes, sir.
Yes, sir.
Shall I change the slide? Okay. Now, second case, how many possibilities are there? You can say there are infinite number of possibilities. We can take K1 is equal to this, K2 is equal to this, K3 is equal to this, M1 is this, and M2 is this, right? But by using the same frequency equation, let's say if you are having any system, something like this, let's say this is K1, mass is M1 here, and here, this is nothing what you can see the K2, and here mass is nothing what you can see the M2. Could you tell me what are the nature frequencies omega n1 and omega n2 is going to be in this case? What is required? Do you want to write the equation of motion? I don't think so. That's required. See, whenever it's a longitudinal vibration, just remember the frequency equation. You have to start from there. What is the frequency equation we are getting for this? M1, M2, omega raised to power 4 minus square bracket. In bracket, you can write it's a K1 plus K2, M2 plus how much? K2 plus K3, bracket close M1, square bracket close omega square plus in another bracket you can write that's a K1 K2 plus K2 K3 plus K3 K1. Is that clear? Let me remind you once again. Means we can have or we can use the same equation to find out the nature frequency, or we can say these kind of the question. Just remember this one. That's more than sufficient to tackle most of the problems which they are going to ask in any GATE exam, or you can say in any competitive exam, or you can say in coming years also. So in this case, could you tell me what is the nature frequency is going to be? Bacho? Yes. Simply write down. Now, you must have the basic understanding, or you can say the common sense here. In this case, how many springs are there? 2 springs are there. And I'm considering this K1 is equal to K. Let's consider the simplest case. And K2 is equal to K. Done. And here I'm considering M1 is equal to M2. U is equal to how much? M. First say yes or no, sir, ladke. It means that the third spring, if you compare with the, you can see the generalized diagram, or which we are taking as a reference, the third spring in this case is what? Absent. Means what? K3 is 0. What is 0? K3 is 0. So just write down the frequency equation. What is the frequency equation we are having? M1, M2, omega raised to power 4. Just write down the frequency equation minus how much? K1 plus K2, M2 plus how much? K2 plus K3, M1 omega square. Exam किसने लिखना है? मुझे या आपने? Hello? You should have to tell me. Plus K1 K2 plus K2 K3 plus K3 K1 u is equal to 0. Just substitute. Look, in this case, the third spring is absent, means K3 is equal to 0. Just substitute here. So how many K3s are there? So this K3 is 0. At the same time, wherever we are getting the K3 means if you multiply anything by 0, it becomes 0 only. So this term and this term are going to be 0, means K2, K3 and K3, K1 are going to be 0. Could you write down like what is our frequency equation is going to be? The substitute M1 is equal to M2 is equal to M. I can write it is going to be M square omega raised to power 4 minus how much? K1 is equal to K2 is equal to K. Again, how much we'll get? It is going to be 2Km plus how much we'll get Bidhi here? K3 is 0, it means that it is how much? Km only. Please take care. And this is going to be omega square plus K square u is equal to 0. Now, if you further like simplify it, you can write that's a M square omega raised to power 4 minus 2 plus 1 is nothing what you can say 3. So you can write that's nothing what you can say the 3Km omega square plus K square u is equal to 0. Find out again. This equation is representing, or you can say it is a quadratic equation in omega square only. Calculate what are the roots of this equation. You can write omega square is going to be apply. Sridharachar, what is that? Minus b plus minus root of b square minus 4ac upon 2a. Even the 7th class student can solve, you can say, these kind of the problems. So in this case, you can write minus b. So it is going to be 3Km plus minus root of b square. So b square is going to be how much? 3Km whole square becomes 9K square M square. Are you getting? Hello, bache? Minus b plus minus root of b square minus 4AC. What is C value? C value is here. This is C. This value is nothing what you can say B here we are considering. And this value we are considering here, capital A or small a, whatever you want to take, minus how much? 4. A value is M square. And C nothing what you can say the K square divided by 2A. So that's nothing what you can say 2M square. So this omega is going to be how much? I can write from here onwards root of kitna aayega ladke? 3Km plus minus root of how much? Could you tell me? 9 minus 4 is going to be 5. K square M square. So we can take this K square M square outside what? The square root. So simply I can write this is going to be Km root 5 divided by how much, bacha? That's nothing what you can say, the 2M square. As you can see, in numerator, M is common. So we can cancel out M in the denominator, means M square. So this omega is going to be how much, bache? It is going to be 3K plus root 5K divided by how much? 2M. Now, obviously, minus sign will be there. So what is omega n1 is going to be? Means the first natural frequency, the lowest one. And what is this omega n2 is going to be? Like the highest of these two. So it is going to be root of 3K minus root 5K divided by 2M. Could you verify, guys? Say something. Yes, and this omega n2 is going to be, just write down with the plus sign. It is going to be root of 3K plus root 5K divided by 2M. Are you getting this one? Please verify.
Yes.
Yes, sir.
Any mistake from my side? If yes, please let me know.
No, sir.
Okay. Now, third case is what? Third case could be, you can see the semi-indefinite system. What it means by semi-indefinite? You can say the semi-definite system. If suppose if one of the natural frequency, look, whether this case or you can say the previous case or you can say the any case, if one of the natural frequency is 0, okay, tell me if the natural frequency is coming 0, what is the meaning of that? Which represent the rigid body mode only. Which mode? Rigid body mode. Is that clear or not? Means it is not vibrating. That's it. Is that clear? Bache?
Yes, sir.
So where we generally use, you can say this kind of the system, even they have asked the question based on this in your GATE exam also. Let me show you. The very next question, I think. Yeah, this one. How many masses are there? 2 masses are there, right? What is this? It's a K here. So in this case, if you are going to calculate the natural frequency of the system, one of the natural frequency is going to be 0 only. Is that clear? Could you check, please? Hello, bache? Could you check?
Yes.
So these kind of the systems are known as the semi-definite or indefinite. Yes, semi-definite system. Please take care. Okay, let's solve another case. Same problem, okay? But here, this is a second case we have discussed. Now, shall I take one more case if you don't mind? Hello? If you don't mind, shall we take?
Yes,
Shall we
sir.
discuss one more case here? Okay. Let's say if we are having two masses like this weight. Let's say this is a rail push, or you can say the bogie, something like this. Let's say M1 equal to M. Okay, just give me a minute. Let's say the mass of this bogie is M. Here, spring. This is a coupling. Again, we are having another bogie or coach, something like this. Okay, done. Let's say I'm considering K and K. So these kind of the systems are known as the semi-definite system. In semi-definite system, what happens? One of the natural frequency is zero. What? One of the natural frequency of the system is zero. That is, the system will not vibrate when the frequency is going to be zero. Means what? That particular mode represents rigid body motion. Which one? Rigid body. Please take care of it. So we have to design, you can say, the bogies based on, you can say, this particular concept only, semi-definite. Now, in this case, how to we can say calculate the natural frequency of system? How many springs are there? Two springs are there. Are these parallel or series? Really? Is it parallel combination or series combination? Just tell me, is this series or parallel? That's it. Take your time. I really want to know. Guess कर रहा है या ऐसे ही बोल रहा है? पहले parallel बोल रहा है, फिर series बोल रहा है.
सीरीज होगा सर.
Huh? It's a series only, na? See, parallel is something like this. Please take care, bache. Parallel is going to be like this. If the springs are like this, is that clear?
Yes.
Then these two springs are going to be in parallel. Is that clear or not? In this case, it's a series combination only. So if the two springs are connected in series, what is the equivalent? You can see the spring stiffness is going to be 1 upon Ke equal to 1 upon K1 plus 1 upon K2 plus dot 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 up to 1 upon Kn. So in this case, it is going to be how much? It is K by 2 only, na? Simple. Even no need to calculate. Yes, please. Okay, find out what is the natural frequencies of this system. Take your time. I'm not going to solve it. I really want to hear from you guys. Take your time.
सर डैम्पर को कंसीडर करना है इसमें और लाइक रिजिड लेंगे वो.
This is not a, it's a coupling. Hello, कभी देखा नहीं? Hello, this kind of, have you seen the rail?
Yes
Rail
sir.
bogies, have you seen? It's a
Yes
coupling
sir.
only. It is simply representing. This is
Okay.
not the damper. Is that clear?
Okay.
Damper symbol is something like this. Please take care. This is the dashboard, or you can see the damper system. This is simply, you can say it's a coupling. Now happy?
Yes sir. The
Hello?
shape was kind of similar, so I misinterpreted it.
Okay, no issue at all. Simply write down it's a coupling. Tell me how much you will get. Yes, बच्चे, how much you are getting? क्या कर रही हो आप? ये हाथ क्यों मिल रहे हैं तुम्हारे? जल्दी जल्दी लिखो। ये क्या लिखा है?
कि वो बाद में स्क्वायर आ जाएगा, इस क्वाड्रेटिक इक्वेशन स्क्वायर
कर जल्दी। Now, I can write here the frequency equation. So, just understand what is the frequency equation. That's a m1 m2 omega raised to power 4 minus square bracket. In a small bracket, what do you have to write? K1 plus K2 m2 plus K2 plus K3 m1 square bracket close omega square plus in a square bracket you can write it's a K1 K2 plus K2 K3 plus K3 K1. That's it. So m square or m1 m2 omega raised to power 4 minus in bracket I can write it's a K1 plus K2 m2 plus how much? K2 plus K3 times of m1 omega square plus how much? K1 K2 plus K2 K3 plus K3 K1 is equal to 0. Done. Now in this case, just we have to understand. While you are going to substitute this value, let me write here. These two springs are connected in series combination. If it is series combination, I can interpret further here. Let's say this is the first bogie having the mass m, and this is nothing what you can say the second bogie. I'm writing this Ke is nothing what you can say it is going to be K by 2. Are you agree with me or not? Hello? Are you agree with me or not? Anyone who is saying it's a 2K? Hello? Anyone who wants to argue why these two are in series? Simply. Now, in this case, compare what is our system we have taken? K1, K2, and K3. So in this case, K2 is nothing but you can say that's a K by 2. What about K1 and K3? K1 and K3 in this case are 0. Means there is no spring here. There is no one more spring in this case, in this fashion, right? Hello? That's how we have considered na? K1, K2, and K3. So in this case, this K3 and K1 both are 0. Means that's a problem. This is given in problem. We are not assuming from our side. So here, just write down K1 is equal to K2 is equal to K3. If you substitute here, what you can write, bache? Yes. How much you will get? Anyone? Definitely. This whole term is going to be 0. First say yes or no, sir. Say yes or no.
Yes,
Yes,
This
sir.
sir.
term is going to be 0, right? Means if you are writing the quadratic equation in terms of you can see the omega square, what we can write? Simply we can write the capital C value is going to be 0. First say yes or no, sir. One more thing, in this case, this K3 is going to be 0, right? But K2 exists. Here this K1 is going to be 0. M1 and M2 are same. So if you substitute this one, or you can say this much information in this, we can write it's a m square omega raised to power 4 minus how much you will get, bache? That's a Km plus Km omega square plus how much? 0 u is equal to 0. Are you getting this one? Please verify. But I think I made the mistake here, right? What is that? It should be K by 2 if I'm not wrong. Say yes or no, sir. Please remember our system, like final one. That's a M. That's a K by 2, right? And this is nothing what you can say, M here. This is our system. Done? So here K2 is given K by 2. So just substitute K2 is equal to K by 2. Then are you getting this one? First verify yes or no, sir. Hello,
Yes.
bacho.
Yes,
Those who
sir.
are online. Okay. It means that I can write here that's a m square omega raised to power 4 minus how much? 1 by 2. 1 by 2 becomes what? 1 only. So it is going to be Km omega square is equal to 0. Even in this case, no need to calculate or no need to write. Yeah, minus b plus minus b square minus 4ac upon 2a. What is common in this case? Hello, Tadke? Yes, I can
Omega
write.
square.
Yeah, very good. I can write. Okay. Shall I write one more step if you don't mind, Bachi? Shall I write? See, this is m square. So shall I write here? It's a m omega raised to power 4 minus k omega square equal to 0. Hello? If we take m is common in this case, then m cannot be 0. The bracket term should be equal to 0. Again, as the Kritika said, we can take omega square again common. It means that what? It is going to be m omega square minus how much, bacha? Please help me. Minus k equal to 0. So simply these are the roots, or you can say the factor of, you are just only factorizing this particular equation. So from here, what you can write? Omega square equal to 0. Another one is what? M omega square minus k square equal to 0, right? So from here, what you will get? Omega equal to root of k by m if you simplify it further, or you can say plus minus k by m. Here, how much will get? Omega equal to 0. Are you getting this one? How much time you can say these kind of the questions will take? Hardly you can say the 2 minutes. If you know, just you have to remember this one. Done. What about the mode shape? If you don't want, if you don't believe me, you can also calculate. Yeah, what you can calculate? The mode shape. So the mode shape corresponds to what? Tell me. The mode shape corresponds to the first natural frequency is going to be what? Please calculate on your own. Since what I'm saying, it's a non-oscillatory motion. So the amplitude is going to be what? 0 only. Check, please, check. Check on your own. If you don't, definitely I will help you. Find out. So how to write down the x1 upon x2? What is the formula? X1 upon x2 equal to k2 divided by how much? K1 plus k2 minus how much? M1 omega square. Just substitute. Calculate. So, okay, let me write one more step. What I can write here as a final answer? I can write omega n1 equal to 0 and omega n2 in this case is going to be root of k by n. So when this natural frequency is going to be 0, it is representing the rigid mode or rigid body movement or rigid body motion of the system. Could you check, guys? Pacho? Simply you can calculate now. X1 upon x2 corresponds to omega 1 is going to be what? K2 divided by how much? Help me. K1 plus K2. Check. How much are you getting? Minus
M1
huh?
omega
Omega n1 square. Substitute here. And what about x1 upon x2 corresponds to omega n2? Just calculate. Okay. Let's solve the PYQs. That's sufficient. Okay. Now, till now, they haven't asked a single question based on like the mode shape, but you should have to know like how to calculate these all things. Okay. Find out. Could you write down the equation of motion? Okay, what do you mean by static coupling? What do you mean by static coupling? What do you mean by dynamic coupling? And what do you mean by no coupling? Let's say, if you remove the spring between these two masses, it is the case of, you can see, no coupling. What I'm saying? How many masses are there? Two masses that are there. Okay. Second thing, how many coordinates are required to specify the motion of this system? Two coordinates, x1 and x2. So what is the degree of freedom? That's a 2. So what is a function of, you can say, this particular spring? You can say this is nothing what you can say. That's a link between these two, or it's a flexible body. Spring is what? Flexible component only. Done. So there is a possibility of what? Or simply you can say this is nothing but you can say this is the coupling between the two masses here with the help of what? With the help of this spring. So if we remove it, then the motion of this mass and the motion of this mass is independent to each other, means that's the case of no coupling. Second one, first one is static coupling. What do you mean by static coupling? If suppose while you are going to write down, or let's say in this system, if you want to write like what is the equation of motion of, you can say this particular system is going to be, then if suppose while you are writing the differential equation of first mass, and let's say the displacement of second mass, what I'm saying, the displacement of second mass x2 comes into the existence, or you can say in the equation of motion of, you can say, the first mass, then we can define that's nothing but, you can see, the case of static coupling. Vice versa, you can also say in the equation of motion of first mass and in the equation of motion of the second mass are having the displacement of first mass as well as the second mass simultaneously. That's a case of static coupling. So could you write down like few points regarding this, if you don't mind? Hello, do you want to write?
Yes, sir.
Write down simply. Write down if equation of motion of one coordinate, if equation of motion of one coordinate contains or possesses the displacement of another coordinates, or you can say mass, comma, such kind of coupling is known as the static coupling. Okay, so shall I prove it? Hello, shall I prove it? I think I should have to prove. Hello, so let's write down what is the equation of motion of first mass and second mass is going to be. Anyone? Here, look, while you are dealing with this 2 degree of freedom, or you can say the 1 degree of freedom, what is the assumptions we are taking? First, we are considering the springs are massless, or you can say the weightless. We are not considering the masses, or you can say the weight of these springs, right? Second thing, during the derivation part, we have taken x2 is higher than x1. And please remember, this is not capital X1, it's a small x1, okay? Please change it. X1 and x2. So what is the second assumption I'm taking? I'm taking x2 is higher than x1. Done? Say yes or no, sir.
Yes.
So in this case, let's say this body is displaced by, you can see the x2 in this direction. Then the displacement of, you can say, the first mass is nothing but, you can say, x1. So could you tell me, like, what are the, or could you mark here the free body diagram? Again, how to draw the free body diagram? Just remember which rule? D'Alembert principle, or you can say the equilibrium method. What do you know? The inertia force always acts in the opposite direction of acceleration, or you can say opposite to the motion. So if this body is displaced in this direction, whether you can see the first mass or you can see the second mass, then what's the direction of inertia force is going to be? That's nothing but you can say m2 x2. Let's say I'm considering this is m2 here, and this is nothing m1. I'm considering this is k1, this is k2, and this is k3. I hope you can relate these all things. Okay. So let's say when this mass is displaced, then the stretching of this spring will take place. Let's say this is nothing what you can see the m1 I'm writing. Again, the stretching in this spring will take place, that for sure. But where is the compression is going to be? Look, if it is moving in this direction by x2, this is also moving by x1 in the same direction. So the elongation in first spring as well as in second spring will take place. But at the same time, as you can see, what happens to this third spring? Is it under the compression or under the tension? Compression. So here you can mark this is nothing but you can see the compression. Done? Now, so here let me draw the free body diagram. It is m1 and this is nothing but you can see the m2. If you know like what is the free body diagram, then equation of motion is like a piece of cake. Is that clear or not? Yes, Maharajji. How much we'll get? That's a K3. This is K2. This is K1. Now, let's talk about the second body, or you can say the second mass, M2 in this case. That's a X2. It means at what? Tell me. what is the direction of inertia force? Inertia force is going to be, yes, tell me, in the opposite direction of acceleration. So this is x2 dot and x2 double dot. Done.
Yes.
At the same time, if this body is moving in this direction, so the third spring is in the compression. So which kind of, you can see the force induced in this spring means internal force. It will oppose this motion or it will try to restore the body. It means that it is going to be like this. Are you agree with me? So it is going to be K3x2. Are you agree? First say yes or no, sir. Bache? Yes.
Yes,
Now,
sir.
in this case, could you tell me, like, see, in this spring, what happens? There is a relative motion between these two masses. What we have assumed, x2 is higher than x1. So we can take, this is nothing but against the x2 minus x1. But most of the time, students make the mistake while they are going to mark the free body diagram for first mass and second mass. How? Take care. The direction of, you can see the spring force in this case is going to be, look, this is spring. Here is the second spring. Try to understand what's happening here. Okay. This spring is under the compression as well as this spring is also under the compression. So could you tell me, like, what is the restoring force or you can say spring force is going to be? What's the direction? Hello? So this is the direction of, you can see the spring force in the second spring now. Say yes or no, sir. Bacho? If it is, if this body is under the equilibrium state, and let's say it is stretched by like this. So this is nothing but it is representing what? These are the spring force or you can say the restoring force. And what is the value of this? It is going to be, yes, anyone? K2 into x2 minus x1. And the same amount of, you can say, the spring force will experienced by this mass here also. So you can write here x2 into x2 minus x1. Please take care. Are you getting this one?
Yes.
Take care. So this is nothing what you can say your first mass. This is nothing what you can say your second mass. So this is the link or you can see the coupling between these two masses. Done?
Yes.
Are you getting? Now, here, what you can mark? Obviously, this is also under the tension. It means that this force is going to be how much? K1, x1. This body is moving in this direction. So x1 dot, that's a velocity, and x1 double dot is nothing but it is acceleration. So what is the direction of inertia force is going to be? Inertia force in this case is going to be, tell me, bache, m1 x1 double dot. And what is the inertia force opposite to the, yes, acceleration, m2 x2 double dot. So could you tell me, like, what is the equation of motion for the second mass and what is the equation of motion of first mass is going to be? Anyone, ladke?
Forces are positive.
See, how much we'll get for the second mass? All the forces, if you look carefully, in the second mass, all the forces are acting in this direction. So what I'm considering, the forces which are acting in this direction are positive. The forces which are acting in this direction are nothing what you can say negative. You should have to take the sign convention. Why? Because the forces are vectors as well as you can see the displacement is also vector. So you should have to define which displacement or which force is going to be positive and negative. Please take care of it. Is that clear?
Yes.
Now, so tell me, what is the equation of motion of second mass is going to be? Simply, it is going to be m2 x2 double dot. What is the direction of inertia force? This one. What is the spring force? This one. What is the spring force? You can say in third spring is going to be K3x3. So I'm getting m2 x2 plus K2 x2 minus x1, right? Plus K3 into x2 equal to 0. From where I'm writing this one? Again, I'm writing from where? Inertia force plus external force should be equal to 0. Are you getting or not?
Yes.
Whether it's a 2 degree of freedom, multi-degree of freedom, or whether it's a case of damped or you can see the undamped vibration of first degree of freedom, I'm going to use the same approach while I'm writing the equation of motion or differential equation of motion for the masses. Done? So what is the inertia force? m2x2 double dot. What is the external force? K3x3 and K2 into x2 minus x1. Tell me how much we'll get, bache. Please help me, bacho. m2 x2 double dot plus here this is k2x2 and this is how much? k3x2. First say yes sir or no sir ladke. Bache, please say something.
Yes, sir.
So it is going to be k2 plus k3 if I'm not wrong. Please help me. Minus how much? k2x1 is equal to 0. Are you getting this one? Hello, bache. Are you
Yes,
getting
sir.
this one? Okay. So this is the, you can write, this is the second equation, or you can say it's a differential equation of motion for the second mass. So I'm taking this is the second equation and this is the first mass. So I'm defining this equation by a equation number 1. Similarly, we can write, look carefully. In this case, the inertia force is acting in which direction? In this direction. The spring force in the first spring is acting in the direction of inertia force. But look here, the spring force which induced, you can say, in second spring is in the opposite direction of inertia force and external force. So we have to use the sign convention. Means this one you should have to write with negative sign. Again, what we are using, inertia force plus external force should be equal to 0. But you should have to know, like, what is the sign conventions? You may take it's a positive or negative. So I can write here, that's nothing what you can say. For first mass, I can write m1 x1 dot plus k1 x1 minus k2 x2 minus x1 is equal to 0. Done?
सर
First
x
say yes
डबल
or
डॉट 1 होगा ना?
yes. I'm extremely sorry. M1 x1 double dot. Extremely sorry. Okay, it's a acceleration, mass into acceleration. So it is going to be m1 x1 double dot plus, look, here we are having k1 x1, and here if you multiply this minus k2 with this minus x1, how much you will get, bache? Yes, it is going to be k plus k2 x1 now. So it is going to be k1 plus k2 x1 minus how much? k2 x2 is equal to 0. Now read how we have defined the static coupling. See, if you look at the equation number 1 or equation number 2, as you can see, while you are writing the equation of motion, or you can say differential equation of motion of, you can see the second mass, then this x1 terms means the displacement of, you can see the first mass is appears, means the first coordinate is also appeared in this case or in this equation. Similarly, while you are going to write down the differential equation of motion of first mass, then this x2 term is involved here, or you can say appears. So this kind of, you can say, the coupling is known as the static coupling. Okay.
Yes.
Is it okay or not? Please respond fast. Read what I
Yes,
said.
sir.
So what is the equation of motion you are getting? कुछ मिस्टेक हुआ है क्या मुझसे? हाँ, कुछ मिस्टेक तो नहीं हुआ ना? फिर बाद में मुझे गालियां निकालो कि सर ने गलत कर दिया. हाँ, प्लीज वेरीफाई फ्रॉम योर साइड आल्सो. प्लीज
नो सर, नो
वेरीफाई.
मिस्टेक, यही सॉल्व करके आया है.
Please verify from your side also. According to me, it's correct. So just you have to draw the free body diagram and just apply which one? Equilibrium method to write down these equations. Shall I remove it? Okay, no need to remove. So this is the question which they asked for 2 marks in GATE 2007. Done? Now, it's a linked question. Okay. Which kind of question? It's a common data question. Means question number 1 and 2 here. So total for 4 marks they asked from this single question only. Done? Again, if you want to answer, like if you want to know, like what is the natural frequency of the system? Okay, wait. Simply what they are asking, the two frequencies of the system are given as, means they are asking which option is correct out of these A, B, C, and D. How to answer this one? It's very easy. Just write down, like what is the frequency equation? Yes, bache. Vidhi, are you there?
Yes, sir.
अनामिका, बच्चे आप क्लास में हो? अनामिका? No. Okay. And Sakshi, are you there? Sakshi? Rohan?
Yes, sir.
Sakshi? Okay, let me check.
Yes, sir.
Okay, Harsh is there. Ritika. Okay, good. Okay. Okay, right on. So to answer this question, what is required? Right on, frequency equation. Which equation? Frequency equation. Tell me, what is the frequency equation for these kind of the system? It is going to be m1, m2, omega raised to power 4 minus in bracket how much? K1 plus K2, m2 plus K2 plus K3, m1 omega square plus K1 K2 plus K2 K3 plus K3 K1 should be equal to 0. Substitute, like what is m1, m2, what is k1, k2, and k3. So in this case, m1 is equal to m and m2 is equal to 3m. What is given in this question? M1 is m, m2 is 3m. Then what about this k1 and k2 and k3? K1 is equal to k2 is equal to k3 is given k. Is that clear? That's what it is given now, k, and k. So just compare. Let's say this is K1. This is the first displacement. Consider this. It is given M1. This is M2. This is K2. And this is K3. Just substitute and find out the natural frequencies. So we can write M1 is equal to M and M2 is 3M. So it is going to be how much? 3M square. Omega raised to power 4 minus. Going to be how much? K plus K2K. K plus K2K. So it is going to be 2K into 3M. Shall I write here? It's a 6 km. M2 is 3m. K1, K2 is nothing but a K. So 2K into 3m is nothing but how much? 6 km. Please confirm. Plus K2 plus K3 is nothing but you can say 2K. And M1 is nothing but how much? Bache, tell me. M1 is M only. So it is going to be 2km. Here it is omega square plus how much? K1, K2. So it is going to be how much? 3k square is equal to 0. Are you getting this one?
Yes.
K1 is equal to K2 is equal to K3 is equal to K. So it is going to be K square plus K square plus K square means 3k square. Now, from here, just find out again, as you can see, it's omega raised to power 4, it's omega square, right? So it's a quadratic equation in omega square only. Calculate like what is the value of omega square is going to be. So omega square is going to be, just compare with minus b plus minus root of b square minus 4ac upon 2a. So it is going to be 2 into 3m square, right? So that's nothing what you can say. I can write that's a 6m square, if you don't mind. Done? Minus b. So this 6km plus 2km is going to be how much? 8km. Bolo yes sir or no sir? Bachcho.
Yes.
So minus becomes plus. So it is going to be 8km plus minus root of b square minus 4ac. So 8 square is how much? 64, if I'm not wrong.
Yes.
So 64 k square m square minus 4 a into c. So a is how much? A is nothing but you can say the 3m square. Please verify. And c is nothing but you can say that's a 3k square. Are you getting bache? Bachi, are you there or not? So
Yes,
omega
sir.
square is nothing but you can write 8km plus minus. Just simplify. 4 3s are 12. 12 3s are 36. 64 minus 36, 24, please. 28. 28. Hello? 36 plus 8 is how much? 44 plus 20. Yeah. 28 I'm getting. Are you getting 28? Please verify.
Yes,
Yes, sir.
So that's a 28 k square m square. So what I can write, bache? I can write here this 28 k square m square is nothing what you can say km. And root of 28, what you can write, bacha? I can write here it's a, if you take the factor, it's a 4 into 7 now. I can write it's a 2 root 7 if you don't mind. Okay. So let me write here. That's nothing what you get 2 root 7 km divided by how much? 6m square. Could you simplify it further? Or I can write here omega is equal to root of how much, bache? See, this is 8. This is 2. This is 6. What you can take? You can take 2 is common. And this 2 and 2 is get cancelled. Means the next step I can write here. That's nothing 4 km. And here I can write 2. So 2 3 are 6. Or you can take 2m is common. So m and this power is gone. Okay, let me write one more step. That's better. Otherwise, 2m. It is going to be how much? 4k plus minus root 7k divided by how much? Could you help me, bache? 6m square, right? So 2 3 are 6. M and power is gone. So ultimately, what you are getting? Please bata de. Please, that's a 4k, right? Plus minus root 7k. Are you getting? Divided by how much? 3m. Are you getting this one? Please verify.
Yes,
Yes.
sir.
Yes, sir. Yes, sir.
Any option? Okay, if you want to write in this fashion, you can write omega is nothing what you can say. You can write it's a 4 plus minus root 7 divided by 3 into k by m also. I can write now. Now check which one is correct. Wrong. This one 4 plus root 3. No, wrong. 4 plus root 7. Yes, option C is correct. This is going to be wrong. Done. Easy or tough? Tell me. See, 2 degree of freedom systems are really very easy if you know or if you remember this one. You are not going to like solve these questions for academics. Even it is for academics, then it is really very, very, very easy. Where is my remote? Remote. Here. I can't see it. On table? Yeah, it's here. Got it, got it, got it. Could you solve this one? Hello? Could you solve it? Say yes or no. Again, this is the question which they asked in GATE 2009, again for 2 marks. Is it easy or tough? It's the easiest question, right? Just write on frequency equation. Please write on first. Write on frequency equation. For 2 degree of freedom system, it is going to be m1, m2, omega raised to power 4 minus in bracket how much? K1 plus K2, right? Times of what? M2 plus K2 plus K3, m1 omega square plus K1 K2 plus K2 K3 plus K3 K1 u is equal to 0. Just substitute the values of m1 and m2. In this case, m1 and m2 are nothing what you can say m1, m2 and k2 is how much? Here you can write. In this case, k2 is equal to k. Since there is no spring, means k1 is 0. No spring is attached at this end. No spring is attached at this end, means k3 is 0. And in this case, m1 is m1, m2 is m2. Just substitute this. Here you can write it's a m1, m2 omega raised to power 4 minus. Since your K1 and K3 are 0, just substitute. K1 is 0 and here K3 is 0. And obviously, this whole term is going to be 0. Why? Because K1, K2, K2, K3 and K3, K1. So while you are multiplying any number by 0, it becomes 0 automatically or inherently. So this whole term is going to be 0 only. So it is going to be m1, m2 omega raised to power 4 minus. How much could you help me, bache? K2 is nothing what I can say K. So I can write here, this is nothing but Km2, right? Plus Km1. Are you getting this one? Please verify, bache. Yes?
Yes.
Or no?
Yes, sir.
Okay. What is common? Omega square is common now here. So you can take omega square is common. It means that m1, m2, omega square minus how much, bacha? Km1, or I can take K as a common here, right? If you don't mind. I can write say m1 plus m2. Are you agree, bache? Hello? Shall I write it in this fashion or
Yes.
not? So just figure out like what are the omega values here. So one value from here you can write omega square is equal to 0, and another one is what? Another one you can see it's a m1 m2 omega square minus k m1 plus m2 u is equal to 0. Just find out what is the value of omega is going to be from. From here you will get omega is 0, like one of the natural frequency is going to be 0, and another one I can write omega is, sorry, anything wrong? Okay, then let me complete. So this omega is going to be, it's a m1 plus m2, are you getting? Divided by m1 m2, right? That's a key. Are you getting this one? Bachcho,
Yes, sir.
Kambi, are you getting this? Omega is equal to root of m1 plus m2k divided by m1 m2. Any option given?
A.
Where?
Yes, first one.
And what is the answer? Okay. So here one of the frequency is 0, and second one is what? K m1 plus m2 divided by m1 m2. It means that option is absolutely correct. Done. How much time it will take? Yes. Here we cannot eliminate the option A, B, or C, or D. Why? Because in each and every case, examiner knowingly given, or since the student understand these all things, it's a semi-definite system. This kind of the system is nothing what I can say, it's a semi-definite system. Means one of the frequency is going to be 0. Done. So which kind of motion is this? It's a rigid body motion. Means the system will not vibrate, or you can say oscillate, when this natural frequency is going to be 0. Done, bacha? Bolo yes or no? These questions are very easy. Huh? Could you tell me, like, what is the concept? There are two modes. One is combined mode, and one is what? Combined mode means what? Linear combination modes. Is that clear? Combined mode motion of two masses are what? You can say the linear combination of linear combination of the linear combination mode motion. Another one is what? You can say it's a pure mode. What do you mean by pure mode? Generally, it's a 2 degree of freedom. How many natural frequencies we are having? 2, omega n1 and omega n2. So for pure mode, what condition it should have to satisfy? First of all, it must have the initial velocity equal to 0. And let's say in these kind of the questions, just as we have discussed these all things, if it is equal to what? x11 upon x12, yeah, extremely sorry, x11 divided by x21. What is this x11 upon x21? This is corresponds to phi 1, means the first mode. Then it will vibrate. Then it will vibrate in the pure first mode only, or will vibrate in first natural frequency only. Done. If in this case, what about the other amplitudes? What happens to this x22 and this x21? Tell me. No. x12. What about these two values? These two values are going to be 0. Means what? The system is vibrating at a single frequency only. Is that clear? Both the masses are means vibrating at a single frequency. So there is no contribution coming out, or you can say comes into the picture from the second mode frequency, or you can say from the second natural frequency itself. Second thing, so this is pure first mode, x10 upon x20, u is equal to, let's say it is coming x12 divided by x22, means it's a pure second mode oscillations. If x10, are you getting what is this x10 upon x20? This is the initial displacement ratios only. So it could be x10 upon x20. I can also write this as a what? x20 upon x10. Is that clear? Just then I have to write this one is what? x21 upon x11 only. Depends which ratio It's easy. Let's say it is coming, it is given 1 and 2 or 2 and 1. So we have to take care of this. X1 0 divided by X2 0 is not equal to the amplitude ratio of both the modes here. So X11, X21 is not equal to X12 divided by X22. So this is nothing what you can say, it's a combined mode. Which one? Combined mode or linear combination of both modes. Is that clear? Shall I remove it? And in this case, please remember, what is the maximum amplitude is going to be? In this case, the maximum amplitude is going to be X11 is going to be X10 only. And this X21 is going to be how much, Larky? Tell me. This X21 is going to be. I have done these all things. I hope you can remind. So these are nothing what you can see. The maximum value of the amplitudes in this case is going to be. Shall I remove it? Yes. So they are saying the mode shape of an undamped 2 degree of freedom system are this, or that. Please remember, in these kind of the question, examiner knowingly provide you lots of data just to confuse you. Is that clear or not? Are you getting? So here what is given? The mode shape of an undamped 2 degree of freedom system are 1, 0.5, 1, minus 0.675, full stop. The corresponding natural frequencies are 0.45 Hertz, 1.247 Hertz. The maximum amplitude in mm of vibration of the first degree of freedom due to initial displacement of 2, 1 in mm and 0 initial velocities is. So write down given data first. What is given? Given data. It means that in this case, if you compare X10, X20 values are given here. How much? Could you help me? That's up 2 and 1. These are in mm only. Is that clear? Okay. Are you getting this one or not? And 0 initial velocity. So how to write down the velocities? Okay. If x1 is the displacement, then x1 dot and x2 dot are going to be initial velocities only. And what do you mean by 0? I'm writing here. Please remember, the motion generally we used to define xt is equal to. Could you tell me how much? X11 cos omega 1 t plus how much?
X12
X12 very good. Sin नहीं आएगा, cos ही आएगा. Sin आएगा ना?
yes.
X11 cos omega 1 t plus X12 sin omega 2 t.
हाँ सर ओमेगा 2 भी रहेगा.
Cos omega 2 t should be there. Sin कहाँ से आएगा इसमें? Sin आएगा.
Cos
सर cos आएगा.
If I'm not wrong, it should be cos.
Yes sir, cos आएगा.
नहीं है सर.
Huh?
Sin.
Hey, could you verify?
सर cos आएगा.
Are you sure?
Yes sir.
Cos ही आएगा. Because at t, look, it should be cos only. Cosine function. See, what I told you, if the initial velocity is 0, then we have to describe these all means the displacement at any time. In terms of what? In terms of cosine function. If the initial velocities are not 0, then just you have to replace the cosine function by the sine function only. तो confuse क्यों कर रहा है भाई? हाँ? X11 cos omega 1 t plus X12 cos omega 2 t. Right? That's the equation. That's a x1. The displacement at any time we can write here. That's nothing what you can say. क्या लिखेगा लड़के? X12, right? Cos. Tell me. Yes.
cos omega 1t.
It should be x21, no? If I'm not wrong.
Yes, sir.
Please verify.
Sir,
Since
omega
the-
1.
Yeah, extremely sorry. Cos omega 1 t. So from where we are getting these are relations? Just by two equations. Look, at t is equal to 0, let me give you some hint. What you can write? x10 is equal to how much? x11 plus x12. What is this x20 is going to be? It is going to be x21 plus x22 only. But you know, if you know the short trick, or you can say like what is the funda, or you can say concept, just compare the amplitude ratio and mode shape ratio. You will get to know like whether they are vibrating in pure mode, or you can say in combined mode, whether it is in first mode or you can say the second mode. Okay, so in this case here 0 is defining at t is equal to 0 what, which is nothing but is the initial condition. Which condition, bacha? Initial condition. So generally we used to define in terms of cosine if the initial velocities are given 0. So here it is given x10 is 0 and x20 is given 0. Please remember, in academics generally we used to like solve these kind of the problems. Just let's say if the initial velocity is not going to be 0, or you can say it is not given 0, then generally same formula we use, but the cosine function we have to replace by the sine function. किया है हमने ये सब चीजें एकेडमिक्स में किया होगा, राइट? नहीं किया तो सीख ले, कुछ एक्स्ट्रा नहीं एफर्ट्स देने इसके लिए. It's very easy topic. So in this case, please remember, if it is vibrating in the first mode, it means that what? Tell me. Means x12 is going to be 0. So what is this x10 is going to be? That's nothing but you can see the x11 only. How much you will get? X11. So this is the maximum amplitude. A maximum amplitude is going to be the initial displacement only. Similarly, what is the maximum amplitude of, you can see, the second mass corresponds to the first natural frequency? That's nothing but you can see x20. Okay, let's solve this problem. So first step in these kind of the questions, I think 4 to 5 questions they have asked. Just very first step you should have to be take, just find out what is the amplitude, sorry, what is the mode shape ratio and what is the initial displacement ratio. Is that clear? So in this case, what is given? Phi1 here is given how much, ladke? 1, 0.5. Is that clear? And phi2 is how much? That's nothing what you can say. It's not 1 upon, it's a matrix. Hello. 1 minus 0.675. And you know very well how we have defined this phi1 and phi2. This is nothing what you can say. Kya ladke? X11 and this is what? X21. X21, not X12. Is that clear or not? And this is what? This is nothing what you can say. That's a X12 and this is X22. So based on this, could you tell me like what is the ratio is going to be? Hello? I can take the X11, the amplitude ratio. Sorry. You can say the mode ratio corresponds to, amplitude ratio corresponds to the first mode. It is going to be x11 upon x21 is equal to how much? Please help me. Yes, it is 1 upon 0.5. That's nothing but 2. Are you getting, ladke? And from here, how much will get? X12 divided by x22 is equal to 1 upon, take the amplitude ratio simply, minus 0.675. Here is my calci. Here is my calci. Just wait. 1 upon 0.6. How much it is? 1.4815. Are you getting? Minus
Yes.
1.4815. Are you getting this
Yes,
one?
sir.
Now, once you get this one, just take what is the initial displacement ratio. From here, what you can write? X10 divided by X20 is going to be how much, ladke? 2 by 1, which is nothing but 2. Just compare. Just compare with, you can say, the mode ratio means first mode ratio and second mode ratio, right? Which one is going to be match, second or first? Here what we are getting? We are getting x1 0 upon x2 0 is equal to how much? This value is also 2. This is matching with our initial displacement ratio. That's nothing but we can see x11 upon x21. That's a 2. Means what? Huh? Tell me, what's the meaning of that? Means they are vibrating in first mode alone. For pure mode motion or vibration or oscillations. Yes, take care of this. Now, whenever we are having the pure mode motion, please take care. Please take care. What is going to be 0? X22 is going to be 0 and X2. No, X12 is going to be 0. Not X12 means the contribution which is coming from the second natural frequency, or you can say second mode, is going to be 0. That's a condition. So here X22 is equal to X12 is going to be 0. Means what? The system is vibrating in a first pure mode only. Okay? Means it corresponds to omega n t is equal to 0. So tell me, how much you are getting, ladke? See, x11 is how much? In this case, this x11 is going to be x10. That's nothing but 2. Simply. And what is this x21 is going to be? That's nothing but you can see the x20. How much it is? It is going to be 1 mm. Please take care. Please take care of it. Done? Please remember always for pure mode oscillations or patterns, this initial velocity should be equal to 0. That you should have to take care. And what is the procedure? Just find out what is the initial displacement ratio. Definitely they will provide in the question, and just compare with the mode shape ratio, first mode ratio and second mode ratio. Let's say in this question, if it is matching with the second mode, it means that what? The system is going to vibrate with, you can see the second mode frequency only. Means what? The contribution which are coming from, you can say the omega n1 is going to be 0. Means what? In that case, you can write x11 is equal to 0 and x21 is equal to 0. That's the means of pure mode. Is that clear? Now let's solve another question. Okay, let's check whether we are getting the correct answer or not. Yeah, answer is given 2 to 2, right? Again, what they're asking, a 2 degree of freedom spring mass system with 2 masses and 2 spring has natural frequencies. Please remember, nothing to do with, you can see the natural frequencies. Just you have to take care, like what is a mode shape? Mode shape of the systems are given by phi1 is this and phi2 is this. Very good. If the first mass is displaced by 1 centimeter, the minimum displacement in centimeters to be given to the second mass to make the system vibrate in first mode alone. Hello, what is written here? If let's say if we want to vibrate the system in first mode alone, what condition it should have to satisfy? Means the initial displacement ratio should be equal to the first mode ratio only. Hello, guys, that's what we have done now in the previous case also. Shall I repeat, or are you getting? If we want the first mode alone, means if we want to make the system to vibrate in first mode alone, it means that it has to satisfy which condition? X1 0 divided by X2 0 is equal to how much? X1 1 upon X2 1. What is this X1 upon X2 2? It corresponds to the phi 1 only. Hello? Find out. Hardly it will take 1 minute to answer these kind of the question. बैठा क्यों बारात में आया क्या? जल्दी निकाल. So what is given? If the first mass is displaced by 1 centimeter, okay? Let's say the initial displacement of first mass is nothing but 1 centimeter. Minimum displacement in centimeters to be given to the second mass to make the system vibrate in first mode is they're asking X20 is. What it means by minimum? Exact. I will explain at the end of, you can say, the process. Now, in this case, what is the value of phi 1 is given, ladke? Phi 1 is given 0.7321, right? Say yes or no, sir. So here you can write simply x11 upon x21 is equal to 0.732 divided by 1. That's a 0.732. Done? Just compare. Add on. Add on. To make the system to be vibrate in first mode alone. What it means by first mode alone is pure mode. Then which condition it should have to satisfy? Means the displacement ratio, initial displacement ratio should be equal to the mode shape ratio or mode shape value, which is how much we are getting? 0.732. Done. So here, what is x10 value is given, ladke? That's nothing but you can say that's a condition. First, we have to take care. This value is 0.732. Here you can write further. This x10 is given 1 centimeter, so you can write the 1 divided by x20 is equal to 0.732. So x20 is going to be how much? 1 upon 0.732. Could you tell me what is this value is going to be, bacha?
1.36.
1 upon 0.732. I'm getting this value is 1.366. Are you getting?
Yes, sir.
1.36612. I'm getting 1202 something. Are you getting this one?
Yes.
So that's nothing but centimeters only. So up to how many decimal places they are asking? Up to 3 decimal places. It means that you can write this x20 is going to be how much? 1.366 what? Centimeters. Are you getting, bachi? Hello? Is it easy or tough? It's really very easy question. Based on this only, they have asked, you can say lots of questions. Shall I change it? Huh? Shall I change this lab? Yeah. One more thing. One more thing which I want to convey at this point. This is not minimum. Please write down somewhere if you want. What it means by minimum in this case? Try to understand. Let's say if we take x10 upon x20 value, then it is going to be how much? 1 upon 1.366, which is nothing but you can say it is going to be how much? You can say it's a 0.732. Now try to understand like what's the meaning of minimum in this case? See, minimum means exact value of x20. Why? If suppose if this value deviates a little bit, let's say whether it is going down or up, let's say if you consider it's a 1.5 or 1.4 or consider it's a 1.2, means pure mode is only and only possible for this case if and only if this x20 is equal to 1.366. Means if x20 value is lower than 1.366 or this x20 value is higher than this 1.366 value, it leads to what? It leads to the combined mode, or linear mode of, or linear combination mode of, you can see, the system. Why? Because if you take any value lower than 1.366 or higher than 1.366, let's say if you are considering it's a 1.4, does the ratio of 1 upon 1.4 is going to be 0.732? No, it is going to be changed. So what is the condition? Means this condition it should have to satisfy. Yeah, x1 0 upon x2 0 should be equal to the x1 1 upon x2 1 to vibrate in the first mode alone. If you are taking this value, means other than this 1.366, what will happen? This condition will not be satisfied. Are you getting this one? Hello, online class. Are you getting this one? Offline? All clear? Okay. Are you getting this one or not? Say something. Yes, please.
Yes, sir.
For
Yes, sir.
example, okay. Consider, let's say I'm considering x2 0 lower than this is 1.2, higher than this is 1.2. Take the ratio. What is this x1 0 upon x2 0 is going to be 1 upon 1.2. That's nothing but 10 by 12. कितना आएगा लड़के? 5 by 6? 5 by 6 is how much? Sorry? 0.833. Does it satisfy, or you can say, is it equal to 0.733? No. For example, if we take another value is 1.5. So 1 upon 1.5 is going to be how much? 10 by 50. What is this 10 by 15, ladke?
0.667.
2 by 3 is how much? 0.666 only, right? But what this value is this? That's a 0.732. So please remember, this is a unique value. What should be the exact value is nothing but you can see the minimum value for this 1 centimeter initial displacement of, you can see, the first mass. Okay. Now that's all. The another question. Again, the highest natural frequency omega of the system is, what it means by highest? Highest means what? Second natural frequency. Please take care. So they can twist the question in coming years like what? Tell me.
Lowest natural frequency or highest?
Lowest natural frequency is what? First natural frequency. Highest means what? In this case, out of these two, that's a second natural frequency. So in this case, what is given? No need to write anything. M1 is M. M2 is how much? M. What is K1? K1 is equal to K3 is given K, and K2 in this case is given kitna bacha? 2K. Just remember the frequency equation. What is the frequency equation? M1 M2 omega raised to power 4 minus how much? K1 plus K2 M2 plus K2 plus K3 M1 square bracket omega square plus how much? K1 K2 plus K2 K3 plus K3 K1 is equal to 0. Substitute all the values and find out. So M1 is equal to M2 is equal to M. So it is going to be M square, right? Omega raised to power 4 minus K1 and K2. So K1 is K, K2 is 2K. So it is going to be how much? 3KM plus K2 plus K3. So K2 is 2K, K3 is K. So again, it is going to be 3KM omega square plus how much, bacha? It is going to be how much? K1, K2. So when it is K1, K2, it is going to be 2K square. Please confirm. K2, K3. K2, K3 is going to be, again, it's a 2K square. And this K3, K1 is going to be K square is equal to 0. Could you tell me how much we'll get? M square omega raised to power 4 minus how much? 3 plus 3 is 6. 6KM omega square plus how much? 2 to 4 plus 5K square I'm getting. Are you getting this one? Please confirm. Hello, bacho? Yes. Now, so this is a frequency equation for the given system. Let's find out, like, this is the quadratic in omega square. So we can write omega square is equal to minus B. So it is going to be 6KM plus minus root of B square minus 4AC. So 6 6 36K square M square minus 4AC. So 4M square. C value is how much? 5 A square divided by 2a. A is nothing but how much? M square only. Hey, is it M1 is equal to M2 is equal to M now? Yes. So this omega square is going to be, or omega is going to be how much? Please bata de ladke. I think the value of M is also given now. Yeah, M is given 10 kg. That's what I want to know. And K value is how much? 1250 na? Hey, we could substitute directly here only. Okay, no need to. So M square. So M is how much? 10. So it is going to be 100, right? Omega raised to 4 minus 6 into K is how much? Please help me. 1250 into कितना? तुझे उधर से ही करना है क्या? डायरेक्टली वहां से सब्स्टिट्यूट करना कर ले, मेरे को कोई दिक्कत नहीं है. लो, hello, if you want to do, okay, you can substitute here. I don't have any issue at all. If you want, you can substitute the K value and M value after simplification of this. Okay, आसान पड़ेगा तो आसान कर ले. So here it is going to be what we can take. See, this is 36, and here how much we'll get? 4 5 20. So 20 k square m square, and this is 36. How much we'll get? 16 k square m square. So 6 km plus minus root of how much? I'm getting 16 k square m square divided by twice of m square. That's what you are getting. First confirm. And from
Yes,
here,
sir.
you can get omega u is equal to, if you simplify it further, how much we'll get, bache? Look, we will get the two values. What is root of 16 k square m square is going to be? 4 km now. So we may have two values. What are those two values? One is positive. So they are asking the maximum, right? So I can write here that's a 6 km plus 4 km divided by 2m square. If I simplify, this is the maximum, okay? So that's nothing but omega 2. It is going to be how much? Please help me. That's a 10 km divided by 2m square. 10 km divided by 2m square, root of this particular value. It means that I'm getting root of 5 k by m. Are you getting this one? Okay, substitute the value. If you want to solve like this, k is how much? 1250, right? And m is how much? 10. Okay, 0 and 0 is gone. It means that what? 125 into 5. How much you will get? 625. Means 25 into 25 is 625, no? 25 some chance of 25, right? So it's a 625 means, are you getting 25?
Yes.
What 25? But they are good. Huh? Please take care. It is in radian per second. If suppose they are asking in hertz, you should have to use the formula omega and it's equal to 2 pi fm. Is that clear? Kritika, are you there? Kritika?
Yes, sir.
Radian per second. That's why the angular frequency. If suppose they are asking in hertz, you should have to calculate like what is a linear frequency. Okay, bachi? So here, this natural frequency means omega n2 is going to be how much? Please help me. That's a 25 radian per second. Okay, let's solve. What is the first natural frequency is going to be? Yes, calculate omega n1 also. So omega n1 is going to be how much? Okay, that's the lowest possible value. So 6 km minus 4 km divided by this value. So how much you will get? That's a 2 km divided by, please help me, 2m square. So this 2, this 2, this m, and this power is gone. Ultimately, you are getting it's a root of k by m. So omega n1 is going to be how much, bache? That's a 1250 divided by 10 root of 125. So I'm getting 125. Kitna? 25 125, 5 root 5 are you getting? Hello? Shall I write here? It's a 25 into 5. So 5 root 5, what? Radians per second. Just calculate and let me know what is the omega n1 value is going to be. Yes, please.
11.180.
11.180.
Yes.
Okay. Radian per second. Up to 3 decimal point, you can write down. Done? Okay. This one again. It's a very simple question, right? क्या बोल रहा है? The two masses of the 2 degree of freedom system shown in figure are given initial displacement of 2 centimeter. Okay, that's a x10. Please remember, If it is initial, means it is given x10 is equal to 2 centimeter and x20 is given how much? 1.24 centimeter. The system starts to vibrate in first mode. Huh? The first mode shape of this system is phi1 is equal to this, where a is equal to going to be. Huh? What is the condition to vibrate the system in a pure mode? Means it's the amplitude ratio, or you can say mode shape ratio, should be equal to the initial displacement ratio only. Say yes or no, sir. It means that just calculate what is x10 upon x20. How much you will get, ladke? That's a 2 divided by 1.24. Could you tell me how much this is coming? Hello, please, for God's sake, tell me how much you will get.
0.62.
0.
So 2 upon 1.24. Wait.
क्या कर रहे हो महाराज?
1.612.
सर मैं क्रॉस मल्टीप्लाई करके कर लिया था, तो मेरे को जरूरत नहीं पड़ा.
Sorry?
1.6129.
एक सेकंड रुकना, क्या बोल रहे? How much it is coming?
1.6129.
1.6129. Are you getting this one? Now,
Yes.
right now, क्या बोल रहा है? The system start to vibrate in first mode. The first mode shape of the system is this one, where A is this. Which case is this? It's a means right now for the system to be vibrate in first mode alone. By default, you should have to remember or understand what the initial velocities are 0. Okay, then only this is possible. And here simply you can write the first mode ratio is going to be what? x11 divided by x21 should be equal to what? x10 divided by how much? Okay, x20. So what is this x10? Please help me. Yes, it is going to be 2 divided by how much? 1.24. So how much you are getting this one? 1 upon 0. Yes, 62 is 120. I'm getting 0.62. Are you getting this one?
Yes, sir.
So means what? What is phi1? Phi1 is nothing but you can say simply we used to write kya? x11 and x21 only. So from here, what you can write? What is the meaning of this 1 and 0.662? Means if the first mass is having the amplitude or you can say displacement of you can say the 1 centimeter, then the second mass, at first frequency is having the amplitude or you can say displacement of what? 0.62 centimeter. Means the relative motion between the second spring takes place here. Means the thing is that, let's say if this is x10 is equal to how much? Let's say it's a 1 centimeter, then this x20 value is nothing but you can say 0.62. Meaning what? There is a relative motion, means x2 minus x1 will be there. Okay, hello?
Yes.
Means relative motion will be there definitely. निकाल इसको कितना आएगा? Yes, come again. What you are saying? So what they're asking simply, this is going to be 1, 0.62. Just compare with what they have given. What is written here? Phi1 is equal to, I can write 1 alpha or A? A. So just compare these two. What is the value of A is going to be? 0.62. Is it clear? What is the possible range is given? 0.61 to 0.63 means your answer is absolutely correct. Is it easy or tough? It's really very easy as well as boring. Most of the students like get confused just by looking at, oh, this much of data is given. Yeah, that's data is given, but it doesn't mean that it's a tough question. It's a really, really very easy questions. Okay. Again, here you will get the clear picture. A 2 degree of freedom spring mass system undergoing free vibrations with generalized coordinates x1 and x2 has natural frequency omega1, omega2. Please, whenever they are asking such kind of the questions, you can say natural frequencies doesn't play any kind of role. That's not required. What is required? Just only take care. Just compare the amplitude ratio and initial displacement ratio. So your first step should be to calculate like what is a x11 upon x21. This is the first mod ratio. It is going to be what? Tell me. Okay. It is going to be what? Please help me. Or I can also take, see, please remember, either I can write in this fashion, or I can also write this one in this fashion. So please take care. In which fashion, or you can say in which kind of ratio or which ratio you are taking. So you have to compare with, you can say, let's say, if you are writing it's a x21 by x11, then you have to compare this by what? x20 upon x10. That's the only difference. Okay. So in this case, what is convenient for us to calculate? x10 is given 6.32. Okay, take same as it is. Okay, calculate x11 divided by x21, 1 upon minus 3.16. Could you tell me how much we'll get? Immediately calculate this one also. Calculate here. x11 upon x21. Please help me. 1 upon minus 3.16. How much we'll get? This is the first mod. Second mod ratio, we can calculate x12 divided by x22 is nothing but how much? Bachi? 1 upon 3.16. Yes, Biti, tell me how much you're getting?
Minus 0.3165.
3165.
5. Yes, sir.
45.
4.5 to 5 round up.
Okay. Here also you will get the same one, 0.3165. It's a positive only, right? Done? Okay. Now, what they are saying, if the system is disturbed with certain deflections and zero initial velocities, please take care. Then which of the following statements is or are true? Means it's a MC, it's a MSK type question, na? Right? So here, an initial displacement of x1 is equal to x10 is 6.32 centimeter and x20 is equal to initial displacement second mass of minus 3.16 centimeter would make the system oscillate with only the second natural frequency. What is the meaning of this? If suppose the system is vibrating with the second mod, look what they're saying, would make the system oscillate with only means what? Pure mode. Is that clear? The second natural frequency. How to find out this one? Just compare what is this x12 upon x22. If suppose this x12 upon x22 is equal to x10 upon x20, it means that what? It's a pure mode, right? It's a pure mode, or it will vibrate in second mode alone. If not, then it will vibrate in combined mode, or what we generally used to call, yes, you can say the linear combination of first and second mode. Okay, Nikal, are we getting or not? So what is this value? x10, calculate x10 upon x20. We are getting how much, Bachi? 6.32 divided by how much? Minus 3.16. How much we are getting? 62 is 36, right? Minus क्या बोल रहा है? Exactly 2. 16 दूनी 32. Yeah, minus 2, right? Are you getting? Hello, Vidhi, are you getting or not? So in this case, what we are getting? In this case, we are getting this x12 upon x22 is not equal to x10 upon x20? Say yes or no, sir. Why? Because it's -2 and this value is how much? 0.3165. Means what? This option is wrong. Why? When these two ratios are not same, means the mode shape ratio and initial displacement ratio are not same, meaning what? They are not vibrating in the pure mode, or you can see in that mode alone. It means that what? It's a combined motion. So please remember, it's a case of combined mode of vibration. Second one, an initial displacement. Are you getting why this is wrong? Because what they are claiming here, they are claiming would make the system oscillate with only the second natural frequency. Wrong. Why? Because these two ratios are not matching. Means what? If they match, then only this statement is going to be correct. Otherwise, what? This is false, or you can say this is not true. But what statement should be true here regarding, you can see, the given initial displacement? If suppose they are saying it's a vibrating in the combined mode, or you can say in the linear combination of first and second mode, then this statement is correct. Second one, an initial deflection of x10 is equal to 10 centimeter and x20 is this centimeter would make the system oscillate with only the first natural frequency. Is it correct or not? Let's check. In this case, already we are having what is the ratio of x11 upon x21? That's a first mode ratio. Here calculate in the second part, or in part B, calculate what is this x10 upon x20 is going to be. Yes, bache, how much you are getting? 2 divided by minus 6.32. How much you will get?
Minus 0.3165.
Minus
0.3165.
3165. So are we getting the same value or different value? Same value. Means what? In this case, it leads to x10 in this option divided, means displacement ratio of the given option, or you can say the given condition, is exactly equal to what? x11 divided by x21. Both are what? Both are minus 0.3165. So is it correct or not?
Yes.
Centimeter will make the system oscillate with only means what? Pure. So are they vibrating in the pure mode or not? Yes. With what? With the first natural frequency. How to identify with the first or second? Take their ratios or compare their ratios only. It means that this option is correct. Option C. What is the option C? Bache? Option C simply. What is option C here? An initial deflection of this and this would make the system oscillate with a linear combination of first and second natural frequencies. Calculate what is the ratio x10 divided by x20. How much you will get, bacha? 2 divided by -2. That's nothing but you can say -1. Is that clear or not? Now compare with both the mode shape ratio. Here what you can write, x10 upon x20 is not going to be equal to what? Tell me. Is not matching with x11 divided by x21 is not going to equal to what? Tell me. x12 divided by x22. I'm not writing this from my own side. Is that clear? We are just only writing just by looking at like what is this x12 upon x22? Like this is the second mode ratio. This is the first mode ratio. So are they matching? No. This is coming -1. This value we have already calculated, minus 0.3165 plus 0.3165. It means that what? This is not matching. It means that what? This system, or you can say for this particular initial displacement of the masses, this system is vibrating in what? This system is vibrating in the combined mode only. So is it false or is it true? They are claiming the system oscillates with a linear combination of first and second natural frequencies. Means what? It's a combined mode oscillations. Is that clear? So is it false or true? Whatever they are claiming is absolutely true here. Done? Now the last option. What is the last option, bache? The last option, they are saying an initial deflection of first mass, that's a x10 is 1 centimeter and x20 is how much? Minus 6.32 centimeter. Just compare what is the ratio first. Then we will look upon like what they are saying. So that's a 1 upon minus 0.622. Could you tell me what is this ratio, bacha? What is
Minus
this?
0.582.
Sorry, kitna?
Sorry. Minus 0.1582.
Really? No, I don't think so. Okay, I did the mistake. 1 upon minus 6.32. Extremely sorry.
Minus 0.1582.
Kitna?
Minus 0.1582.
Really? कितना बोला तुमने?
Minus 0.15822.
इसका हाफ आना चाहिए if I'm not wrong.
नहीं तो इसमें 1.5
इसका हाफ ही आ रहा है because it's a 2 upon, it's a 1 upon. कितना आ रहा है? Minus 0.1582. Okay. Just compare with what they're saying. An initial deflection of this and this centimeter will make the system oscillate with only the first natural frequency. Means what? Whether it is in pure mode or not. Alone means what? Pure. Are these two ratios are same? Here, x11 upon x21 is how much? Minus 0.3165. And here how much you are getting? Minus 0.1582. Meaning what? These two ratios are not same. What's the condition for the pure mode? Means the amplitude ratio should be equal to kya? Please tell me. Amplitude equal to mod shape ratio only. So it is going to be what? It's not going to be equal to x11, x21 means it's not equal to the mod shape ratio. It means that what? It's a combined mode. What is the possibility? Combined mode means this option D is wrong. So what is the correct one? Option B and option C. Is that clear? Okay. A uniform rigid prismatic bar of total mass m is suspended from a ceiling by two identical springs as shown in figure. Let omega 1 and omega 2 be the natural frequencies of mod 1 and mod 2 respectively. Even they have written in this case, right? Means omega 1 is lower than omega 2. The value of omega 2 by omega 1 is. Tell me, what the value of omega 1 is going to be in this case? See, I think we are having one equation, right? Which kind of, you can say mod is this? We have already discussed in the class. Which kind of mod is this? It's a combined, it's a rigid. Which one? Rectilinear and angular mode. Combined rectilinear and angular mode. So in this case, we are having two conditions. What are the conditions? First condition, K1 L1 is equal to K2 L2, right? Second one is what? K1 L1 is not equal to K2 L2. Are you getting? First say yes or no, sir. Clear? So in this case, where the CG? Is it visible? So obviously, this point, midpoint here is going to be center of gravity, right? That's a CG only. If this total is L, could you tell me like what is going to be? This is going to be L by 2. This is also going to be L by 2. And total is how much? Total is L. Here, consider this is K1 and this is nothing but K2. Hey, is this visible to you or not? This blue color? This blue color is visible to you or not?
Yes, sir.
Yes, sir.
Visible, sir.
Huh? Visible? Okay. Means in this case, if you compare, consider this is L1 and this is L2, means here K1 L1 is equal to K2 L2. Satisfying or not? Check. K1 L1 is how much? Let's check what is K1 L1 value first and what is the K2 L2 value. So K1 is nothing what you can say K, L1 is nothing what you can say L by 2. So KL by 2 and this is also KL by 2. So it is satisfying the condition K1 L1 is equal to K2 L2. Now you should have to tell me what are the frequency formulas for this particular case. Yes, what is omega n1 and what is omega n2? Root of anyone? I think it's a k1 plus k2 by m. Could you verify? सिर्फ yes ही बोलेगा या फिर कंफर्म भी कर रहा है? k1 plus k2 by m, and for this one it is going to be how much? k1 l1 square plus k2 l2 square divided by I. Is that clear? k1 plus k2 by m, and omega n2 is going to be how much? k1 l1 square plus k2 l2 square divided by how much? Divided by I. Please remember, in this case, there are two kind of motion. One is what? One is nothing what you can say, rectilinear motion, means this body is moving up and down, something like this. At the same time, okay, let me change the color. This body is moving up and down. So which kind of motion is this? You can say it's a rectilinear motion. At the same time, one more possibility is what? You can say this body is moving like this, means pitch up or pitch down, or you can say the nose up and nose down. So this kind of motion, most of us have sensed, you can say, during our lifetime. Could you give me the example of this? If you apply the brake, let's say if you are having the vehicle, let's say whether it's a 4-wheel, let's say this is any vehicle. Let's say replace this by a spring here, you may consider. So in this case, what happens? Let's say the CG at this point. So in these kind of the problems, what happens? Anyone? The center of gravity and center of rotations are not the same point. What's the center of rotation? Means about which you can see the angular motion of the bodies takes place, or you can say rotation is takes place. And CG is what? CG, where the total weight generally X, or you can say the weight distributed equally, or what you can say, the weight is concentrated at that particular point. That's how we define the center of gravity. Say yes or no, sir. So in this case, CG is here, and center of rotation is not coinciding with this CG. Then what happens? Two motions are possible. So when you apply the brake, generally the vehicle means start oscillating like this. At the same time, one more oscillation like this only. Even if you apply the brake of scooty, or you can see the bike, we generally sense this motion, right? It goes like this, nose up and nose down. At the same time, the motion in the rectilinear, or you can see the vertical direction, something like this. Have you seen? Have you sensed it or not? फील किया है या नहीं किया है? हाँ, बाइक चलाना तो आती होगी, बोलो हाँ या ना?
Yes, sir.
तो बस वही है, कुछ नहीं. Second case is what? For second case, please remember this one. They can ask for second case. Which one? Let's say if K1 L1 is not equal to K2 L2, then could you tell me in this case what the frequency equation is going to be? Anyone, ladke? Yes, anyone?
Sir, half bracket में b plus rho square minus 4c.
वो सबको पता है. I mean to say, tell me what is the frequency equation. I really don't want to like confuse you, like what is the A, what is B, and what is C.
ओमेगा टू द पावर 4 माइनस ब्रैकेट में k1 प्लस k2 अपॉन m प्लस k1 l1 स्क्वायर प्लस k2 l2 स्क्वायर अपॉन.
एक मिनट, फिर से आना, फिर से बोलना क्या बोल रहा है, फिर से आना भैया.
ओमेगा टू द पावर 4 माइनस ब्रैकेट में k1 प्लस k2 अपॉन m प्लस k1 l1 स्क्वायर प्लस k2 l2 स्क्वायर अपॉन i ब्रैकेट क्लोज ओमेगा स्क्वायर प्लस k1 k2 ब्रैकेट में l1 प्लस l2 होल स्क्वायर अपॉन mi.
ओमेगा रेस पावर 4 के साथ और कुछ नहीं आएगा? m1 m2 नहीं आएगा? चेक 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 चेक, कंफर्म कर एक बार, ऐसे नहीं होगा. correct. C, it is going to be omega raised to power 4, right? Minus. Look, how to remember this one? If you can remember these two formulas, don't panic. Really don't panic. Whatever inside the root, it is going to be here only. K1 plus K2 by M plus how much? K1 L1 square plus K2 L2 square divided by I bracket close omega square. Easy or tough? NG? Bache? Are you getting this one or not?
Yes, sir.
And here plus it is going to be K1 K2 L square divided by my IM or my means MI is equal to 0. What is L here? Hello, what is L? I generally used to like remember like this. L is equal to L1 plus L2 only. Hello, what is L here? Total length. If you want, you can keep it L1 plus L2 whole square also. I don't have any issue. Or you can keep it as a L square. Hello. Hey, this blue color is visible or not?
Yes, sir.
Visible, hai na? Okay. Are you getting this one, bacho?
Yes, sir.
So let's say you can take this question as your homework. Same question, okay? K1 is equal to K, K2 is equal to K, right? But let's say the center of gravity means CG is acting at Ly3 from here. Means let's consider the second question. Let's say the CG lies at this particular point. You can see this is nothing Ly3 and this is going to be 2Ly3. Calculate what is the nature of frequencies are going to be omega n1 and omega n2. Could you calculate? So this case and the question which I'm asking you here, like consider L1 is equal to Ly3 and L2 is equal to 2Ly3 are going to be same or different? It is having the different frequencies. Why? Because it will not satisfy which case? K1 L1 is equal to K2 L2. In this case, the midpoint is nothing but against it's a center of gravity. But when you are defining the CG lies at a Ly3 from this end and 2Ly3 from this end, definitely KLY3 is not equal to 2KLY3. So what you have to apply? This one. Just L1 is how much? Ly3. What is L2? 2Ly3. And most important thing which you should have to remember in this case, what is value of this I? 99.99% student make the mistake in substituting the value of I. Anyone? See, this motion takes place about the CG only. Is that clear? That's a clue point. Hello, shall I repeat? This motion takes place like this. What about which point? About the CG. So which value of I is mass moment of inertia you should have to substitute? About this end, about this end, or about the CG? About the CG only. So till you can say the last class, or you can say last class, in most of the times, we have considered the system is vibrating about one of its end, something like this. Say yes or no, sir? It was vibrating like this, right?
Yes, sir.
So we were taking the mass moment of inertia about the one of the end of this rod. But in this case, the motion is like what? The motion first, something like this. At the same time, simultaneously, the motion is like this only. Is that clear? It is going up as well as down, as well as it is having the angular motion, angular mode and translation motion. Is that clear? Means if I want to show you like separately, means the system is moving like this. At the same time, it is moving like this. Okay, done. So I value is what? About the CG only. Please take care of it. So what is the value of I is going to be in this case? I is going to be ml square by 12. So if we substitute I is equal to ml square by 3, means it is going to be wrong. Calculate. What is omega n1? Omega n1 is equal to, it is going to be, what is k1? Is k, what is k2? K. So it is going to be 2k by m. Let's see whether we are getting the correct value or not. Omega n2 is going to be how much, Lord K? That's a k1 is k, KL square by 4 plus how much? KL square by 4 divided by I. I is going to be, please help me. That's a ML square by 12. Simplify it. How much will get? It is going to be, yes, 1 by 4 plus 1 by 4 is 1 by 2 now. So it is going to be KL square by 2 divided by how much? ML square by 12. So this L square and this L square is gone. First say yes or no, sir. So, and this 2 6 12 I'm getting, right? I will get this value as a 6K divided by M. Are you getting bache? Please help me.
Yes.
Bacho, are you getting this one or not?
Yes, sir.
हाँ यही है
Are you getting this or not? लास्ट में गालियां तो नहीं दोगे मेरे को? वो बच्चे क्रिकेट खेल रहे हैं नीचे, वो उनकी बॉल आ गई, प्लीज वो गेट ओपन करके आ, परेशान करेंगे, जल्दी जा, जस्ट ओपन करके आ जा, ठीक है now. So this is nothing equation number 2 and this is nothing but against the equation number 1. Okay, the value of omega 2 by omega n omega 1 is going to be what happened? Now simply what they are asking, the value of omega 2 by omega 1 is going to be, so omega n2 divided by omega n1 is going to be what? That's a root of 6k by m into how much? M divided by 2k. Are you getting bacha? So this m and this m get cancelled, this k and this k get cancelled, and 2 3 6. So I'm getting root 3. What is the root 3 value? 1.732. Say yes or no, sir. What is the root 2 value? Yes. What is root 2? Hello. What is root 2? 1 point. Yes. Anyone?
1.414.
Very good. So up to 2 decimal places or 1 decimal places? Round up to 1 decimal place. So I can write up to 1 decimal place, this value is going to be 1.7. Is it easy or tough? Hello? Bachi? Easy. Find out this one also. So what we generally take? We take x1 is equal to capital X1 sin omega t and x2 is equal to how much? Tell me. That's a x2 sin omega t. So what is a x1 double dot is going to be? That's nothing but minus omega square x1 sin omega t, and this x2 double dot is going to be how much? Minus omega square x2 sin omega t. Just substitute here and find out what is the value of x1 upon x2. Substitute in equation number 1 and equation number 2. Equate it, and what you will get? You will get the frequency ratio. So what I can write here? Okay, m in bracket minus omega square x1 sin omega t bracket close plus 2k x1 sin omega t minus k, that's a x2 sin omega t is equal to 0. Simplify it. What is common? Sin omega t is common. Sin omega t cannot be equal to 0. So just we can make the system, or you can say this equation equal to 0 by keeping m omega x1 x2 whatever we are having, right? So what I can write here? It's a minus m omega square x1 plus 2k x1 minus kx2 is equal to 0. Say yes or no, sir, bache? From here, could you tell me like what is the value of x1 upon x2 is going to be? Just calculate the value of x1 upon x2 from here. Anyone? Yes? What I can write? I can say this x1 in bracket how much? 2k minus m omega square is equal to how much? Please help me, ladke. Please. That's a kx2 now. Say yes or no, sir. What is this x1 upon x2 is going to be? That's nothing but K. Why I'm writing K? Yeah, K is here, that's why. So it is going to be K divided by how much? 2K minus M minus. Are you getting this one? First say yes sir or no sir, Bachi.
Yes, sir.
So this is from equation number 1. Or even directly I can write x1 by x2 is equal to how much? K2 divided by K1 plus K2 minus how much? M1 omega square. थोड़ा भी common sense होगा. You can consider this system is something like this only. It is going to be like this only. Similarly, calculate like what is the x1 upon x2 if you substitute the value here. You can write that's a m in bracket how much? Minus omega square x2 sin omega t minus k. X1 value is how much? Sin omega t and plus 2k x2 sin omega t is equal to 0. What is common? Sin omega t is 0. So sin omega t cannot be equal to 0 means what? The remaining equation is going to be 0 in this case. So it is minus m omega square x2 minus how much? Kx1 plus 2kx2 is equal to 0. What is required? X1 upon x2 ratio is required. So what I can write, bacha? I can write here kx1 is equal to what I can write? 2k minus m omega square times of x2. Could you verify this, please? Bacha, could you verify, please, for God's sake?
Yes, sir.
So I'm getting this x1 upon x2 is nothing but kitna? 2k minus m omega square divided by k only. So during the derivation part also, you know what? Generally, instead of k1 plus k2, we generally get k2 plus k3 only, right? Say yes sir or no, sir? During the derivation part. And just this is nothing but you can say reverse of, you can say this value is going to be what? It is going to be 1 upon this particular value only. So consider this is A and this is B. If you want like what is the frequency equation is going to be, simply equate x1 upon x2 from equation 1 and equation 2, which is nothing but you can say expression A and expression B. What you will get from here? What you will get? Frequency equation. So shall I remove it or shall I use the different slide? तब से क्या कर रहा था? आलसी हो गए, प्रमादी बिल्कुल तरीके से तुम. So x1 upon x2 is equal to how much? Could you tell me? That's a k divided by 2k minus m square. And this is A. And what is B, bacha? X1 upon x2 is equal to, we are getting kitna? Please help me. 2k minus m omega square divided by k. Just equate these two expressions. So since x1 upon x2 value is going to be same, right? Whether you are calculating from equation number 1 and equation number 2, which is nothing, simply it is representing the mod shape. What it is representing? Mod shape. So equate ka, we can write k divided by 2k minus m omega square is equal to 2k minus m omega square divided by k. Is it correct or not? Hello? Please take care. कुछ मिस्टेक तो नहीं हुआ ना मुझसे? Please. I think it's correct. So tell me how much we'll get. K square is equal to 2k minus m omega square whole square. Tell me how much you're getting. K square is equal to what is a minus b whole square? A square plus b square minus 2ab. So it is going to be how much? 4k square plus m square omega raised to power 4, right? Minus how much? Twice. So 2 to the 4k m omega square. Are you getting this one? Let's say yes or no, sir. 2 to the 4 km omega square. So just simplify this. What I can write here? Take this k square to this right hand side, and I can write here m square omega raised to power 4, right? Minus 4 km omega square minus how much? Plus 3k square is equal to 0. Why? 4k square minus k square is going to be 3k square. What is this? This is nothing. Simply we are getting the frequency equation. I can also solve this question with the help of, you can see, the matrix by writing the mass matrix and you can see the stiffness matrix, but that's not required. You should have to know like what are these things and tell me, and it will take, you can see, the less time in comparison to the matrix method. Tell me how much we'll get, please. Omega, that's a minus b, so you can write it's a 4km plus minus root of b square. So 4, it is going to be 16k square m square minus 4ac. So what is a value? 4m square. What is c value? Into 3k square divided by twice of a. So it is going to be 2m square. So omega value is going to be how much? Please help me, bacha. What they're asking? Okay, they are asking the value. Okay, just wait. The larger value they are asking, right? Larger means what? Second nature frequency. So from here I can write it's a 4km plus minus how much? 4 3s are 12. 16 minus 12 is how much? 4. So root of 4k square m square is going to be what? 2k. क्या बच्चा तू क्या करता है? Are you getting this one or not? Let me write one more step, otherwise you will get confused. क्या हो रहा है? क्या हो रहा है? Done? So from here I can write omega is equal to how much? Root of 4km plus minus how much it is? 2km, right? Divided by 2m square. So if I want to simplify it further, what I can write? It is going to be, see, take 2m is common. So what I can write here? It is going to be 2k, right? 4k. I'm saying take this 2m common and cancel out because it's a 2m square. And here it is going to what? 2k plus minus of what? K divided by how much? Divided by m. Hello. Take 2m is common in the numerator and cancel out. You will get this expression. So omega is equal to how much? They are asking like the larger one. So omega n2 is going to be larger one, which is nothing what you can say. 2k plus k divided by how much, bacha? M. What is omega n1 is going to be? Root of 2k minus k. Say yes or no, sir. होता क्यों है? Root of k by m. कुछ भी नहीं है इनमें. pk by m. So क्या बकवास कर रहे हैं वो? They are asking like what is this a value, right? K by m. So what is the root 3 value? That's a 1.732 root of k by m. Could you compare with the highest value of frequency with this a? It is going to be 1.732. Could you tell me like what is the answer? Yes, that's what they are getting. Yes. 1.722 to 1.74. So if you want to write this particular value, a value we are getting, it's a 1.732. That's a root 3 only. Up to 2 decimal place, we can write it's a 1.7. That's the answer. Are you getting this one? Please verify. देखा नोट्स अपने? तू निकाल रहा है, कॉपी कर रहा है?
Sir, is there a shorter approach to solve the same?
Which one?
The same question, can it be solved like in less amount of time?
I can solve it, but that's not required. Is that clear or not?
Okay, sir.
Follow the approach in which you are master. Okay? Otherwise, second approach के चक्कर में जो आता है वो भी निकल जाएगा. Just calculate x1 upon x2. That's it. Are you getting this one or not? Okay. Okay. That's the end of this lecture. And I'm starting, you can say, GATE 2026-27 batch from the next month onward. Those who are interested can contact me or can contact us at this number 8698732400. Thank you all of you. And tell me one more thing. Like What about, let's complete the remaining portion also. Hello, we can take the class by 1 o'clock or you can say by 2 o'clock. I don't have an issue. Do you want to join? You should have to join. Thank you, all of you.